Aloha, everybody, and thank you for joining us for this session on communicating science in the age of social media. I hope you enjoyed the previous three talks in the series and that you will join us for the live panel discussion on Friday, July 26th at 8:30 a.m. and 3:30 p.m. Hawaiian time. Let me now share my screen with you. My talk will focus on using the internet and particularly the vast amount of data that is now available online as a tool to enhance teaching and learning. I will explain the rationale for engaging students with data-based learning and how this is best done. I will also share some examples and resources and briefly mention a couple of ways to include various other social media and web-based platforms as a component of teaching. So collecting, analyzing, and using data is core to what we do as scientists. And with current technology and expectations from funding agencies, journals, and societies, we're able to share our data broadly through various repositories and online data access infrastructure. And although we'd love our students to learn how to collect their own data and use their own data for interpretation, unfortunately, this is not always practical due to time, budget, accessibility, and other constraints. But many of these limitations can be removed if we use authentic data that is already available on the internet as an integral part of teaching. These data are typically easy to access, they're of high quality, and have high spatial and temporal coverage. I also want to mention that in addition to using this data for our teaching, by using such data, we're providing useful skills to our students that are useful for their day-to-day life, like reading newspapers, using their apps, or looking at their electric bill in this case, but any other thing. So that's really a useful thing to do. So what do I mean when I say teaching with data? Any learning process that uses observations as a fundamental component of the learning enterprise will be considered teaching with data. However, in this specific case, we want the data to be the center of the experience the students are having in the learning process. The data will inform what the students do, what the students know, and how the students think. So this has to be deliberately done with the focus on the data. And then that data could be used to support students' inquiry, to support their ability to evaluate the data, and to improve their quantitative and critical thinking skills. There's lots of reasons to teach with data. Most importantly, using existing real-time or archived data can explain students or help students learn about physical processes that are relevant to their life. And also, as I said, provide them with this tool set to be able to analyze and interpret data, which is a useful skill. Studies have shown that when we use evidence to construct testable explanations and predictions, this helps students develop their geoscientific reasoning skills, improve the depth of their understanding, and enhance the retention of the content. It also, as I said, build skills that are relevant to a wide range of professions and help them assess real-world life complex problems. It also helps with increasing their verbal, written, and graphical communication skills and expose them to the ethics of working with data. So how do we start? This sounds easy because we all use to some extent data in our teaching, but as I said, this has to be deliberate, which means that we have to use or be able to reform or redo or revise our classes and be willing to lose some control over the classroom because the students are going to be doing most of the learning themselves. Unfortunately, or fortunately to some degree, data is messy and they don't come with the instruction manuals. So thought has to be invested in creating the assignment such that the student's learning experience would not be frustrating, but actually will be productive and useful. And also it's important that the specific lesson or unit will be well situated within the context of the course. For example, if you can see here, these are data sets, and you can see there's a lot of information here. There is a short time scale fluctuations, there's long time scale changes, there's break in the data, there's all these spikes, and then there's two data sets that are somewhat different from each other that could be compared. So there's a lot of information, and we need to intentionally decide how we're using this information for our students, and that will depend on their background and the context of the classroom. So there are several questions we need to ask in order to do that. First of all, it's what do you want your students to learn from this lesson? And here, as I said, you have to be deliberate, you have to know exactly your goals, and it has to be aligned with the course goals. Second, you have to think about what kind of data do you want your students to work with? And again, this could be raw data, process data, figures, images, models. The data could be global in nature or local in context. You also have to think about how you intend the students to engage with the data. That means, would they have focus questions, open-ended questions? Do they have to replot the data? Would they work as individuals or in groups? And finally, what are the research strategies you want the students to use? That is, would they use observations, descriptions? Would they experiment with the data? Would they include that in models? As you notice, I highlighted here the word students throughout, because in order for designing a successful data-based teaching structure, you have to think about the students, their knowledge, and what they can or cannot do. You don't want, that's a lot of work that goes on your behalf or on the students into designing that, so you don't really want this to be a frustrating experience. So first and foremost, you have to make sure that the data exists, that it's accessible, that the tools that you want the students to utilize are working, and that they get clear instructions, and also that if they need help, help is available. Kastens and Krumhansel in 2017 published a really nice summary of how to identify curriculum design that fits the different strategies for education with specific emphasis on the geosciences. And they were able to show 6 different examples of how to use data in teaching, starting from a relatively simple example over here, where you use authentic data to reinforce a widely taught scientific concept. So the students have already learned something, and you want to link that into demonstrating that what they learned is relevant for real world situations. So they look at the data, and then they get an aha moment that they realize it's important. For example, over here, students have learned about a pollutant transport, and they get to analyze an example of the Love Canal over here. They see videos, they look at data, and based on that, they can reinforce their knowledge about distance from the source of pollution and permeability of the substrate in terms of controlling pollutant transport. If you go further on, you can have 4 different data sets in this here, so it could be different data set that combined information from these different ways of explaining or examples of explaining, help students construct a broader and deeper view of a specific phenomena. And again, they get the different data types, and they have to analyze with instructions. They can also use data to recommend decisions based on this data, or we can go to more and more complex examples. For example, here they have some data pattern that they have to observe, explain, and then use that for predictions. Or they can have 2 distinct data sets that they interpret together to inform or get new concepts from these data. And finally, over here, there's an example where they're given data sets, and they actually, based on these data, construct a new type of data on their own. So there's lots of ways to use data for teaching. I want to go and show thoroughly one example, and in this case, I'm showing you a unit that is called Marine Oxygen Isotopes and Changes in Global Ice Volume, and it's part of a class or a course on geology of climate change and energy that was developed at SUNY. So just to give you some background, the students have already learned about isotope fractionation associated with water evaporation and precipitation. And here they're using this knowledge specifically to analyze global ice volume. So these are the goals that the instructors have identified for this specific unit. The students need to identify the patterns of changes in oxygen isotopes of benthic foraminifera and use that to calculate changes in ice volume. And in terms of tools, they'll be evaluating, plotting, and quantitatively analyzing the data. So how does that look like? First of all, there's a very clear instructions. The instructions put the unit in context of the general class. So you've learned this, that, or the other. In this exercise, you will do the following using the following Excel spreadsheet. So there's very clear information. And then the actual activity is scaffold. It has 3 parts. Scaffolding helps both the students kind of move from one assignment to another or one step to another. It also helps in actually grading the class, so you don't just give one grade, you can see how the student progressed. So the part 1 start with a quick review of the context of oxygen isotopes. It could be a figure and a couple of questions to remind the students about what they've already learned. And then this is really the most important part. How do they access, plot the data? And you can see here, there's clear instructions with links. Go to this web page, follow to this link, and then go to the data that's over here, copy this and copy that. And this is really crucial that all of these links are working and live and tested. Then there's instructions about organizing the data, copy from this column to that column, open this Excel spread template, and so on. And then instructions about plotting the data, create an XY plot of the oxygen isotopes on the y-axis, the time on the x-axis, and finally the third part, the interpretation. There's a series of questions starting from describing the data all the way to interpreting the data and calculating the new information about the ice volume. So this is one example that shows you how the data is the center of this whole learning process. This is another example here where that lends itself very nicely to group work. And over here, different groups get assigned an estuarine reserve site, and all of these sites have a temperature information, and the students look at the temperature variability in each of these sites. And this is just the first page of the curriculum, so there is a link to the rest of it right here. Generally, the data could be images, graphs, plots, and the questions could be specific or open-ended. And then the assignment could be given either before or after the lecture. Work can be done as individuals or teams. And at the end, obviously, the students have to present some work either by solving the assignment or giving oral presentations. So this is a lot of work, but luckily there's also a lot of resources for that. Here I show you the circ-carleton.edu webpage where I Googled and found that there's 200 matches for designing classes using data. You can see here, there's information about all of these sites, what level, what content. Luckily, there's about 165 matches for geosciences and a lot for environmental science and geography as well. The oxygen isotope one is also, example also comes from this webpage. And there's lots and lots of other examples as you can see here. There's also lots of data archives that you can use. Here are some links that I've used before, but there's many, many more, and you have to search them, make sure they're available, and test them for your own needs. Finally, in the last couple of slides that I have, I would like to talk about including other social media in terms of teaching tools. This is a study that asked teachers what they use. You can see quite a few teachers use blogs, but still not as many as probably we could or should be using. And the reason or the barriers are mostly that the teachers don't think that these tools are designed for teaching, and then they're also worried about the bureaucracy and support for the infrastructure. There's also concerns about the students' ability to use these social media. I wouldn't worry too much about that because I think the students actually are very familiar with these platforms. So if we overcome our hesitation, it should be pretty easy to access these social media tools and use them for our teaching. Here are some examples of social media tools I've used in my teaching. I use blogs, and you can see here from my experience, I would say with blogs, you have to clearly articulate the rules of blogging. What are your expectations? How many blogs per week? What kind of content has to be assigned and clear in advance? You also want to discuss plagiarism and to keep the momentum, make sure that students are active all the time. Another platform that I've used is called Story Maps. This includes some, it's more complex. It includes some knowledge in GIS, but there's lots of very clear tutorials on their webpage that could be very useful if you want to use that. Finally, I've not done that, but Jen Glass, one of our speakers, used Wikipedia or editing Wikipedia as part of a class that she taught, and the response for the students were very, very favorable. They managed to add and edit a lot of concepts, as you can see here, and hopefully you can ask Jen more about that when during our panel. And with that in mind, I would like to thank you all for participating. This is my email over here, and you're welcome to send me questions if you have any later on. So thank you all again, and mahalo.